Welcome to the Pettitshire Pan Pals. My name is Antonio,
And I am Nathaniel.
and we are brothers with each other.
Very much, extremely brothers. We're very much brothers.
We're still brothers after all these years.
After all these years. So how are you doing, my brother?
Well, fair to middling, can't complain. Doing a little home improvements with my pandemic. So I've been, getting out stud finders and drills and
cans. Goodness, how masculine and rough and tumble of you.
Yeah, it really is building up my cred, which I guess there was no reason that I couldn't have done that before, but
right.
I don't know. There's something about I've lived in my current apartment for about a decade. It was 10 years last year, and I always kind of had it that this was just a temporary waypoint, just stopping through. So no need to kind of put down roots. So I unpacked, but just there were certain things that I just never got around to doing. Like the apartment wasn't fully painted when I got here, and so there's always been like splotches of paint.
Right. Yeah, that's right.
Covered up some. Yeah. So I'm finally just getting around to I should just paint the walls. So now I'm painting the walls. I'm rearranging the place. Yeah, just kind of reinvesting in the home. I talked a little bit about this before, investing for me, right? So
right.
let's say that entertaining is over for this moment, and let's see how we can entertain ourselves.
Yeah, that's right.
How about yourself? What are you up to?
Well, boy, what am I up to? I've been entertaining myself in various ways, and the most I wish I could say they were all exotic. I wish I could say that I was doing lab experience. Oh, I've been off cracking atoms. No, I've been doing very pedestrian. I've been watching cartoons. I've been playing a bunch of video games that I meant to try out during regular, normal, non-apocalypse days, and finally getting around to. I'm actually that I'm deriving an unjustifiable amount of satisfaction from getting around to exploring games that I always meant to explore.
Well, good. Any standouts that you can share with the class?
Yeah, I guess. If the class, maybe
hashtag VR bros you or anything, but
right, yeah, no, the most there's not that much that I think that you would necessarily fall in love with. Maybe somebody out there in TV land is familiar with the Disgaea series of strategy RPGs, but I'm just getting into them now, and they're really excellent. They're hilarious. They're these comedies about the underworld, about the netherworld, but that everybody down there is demons, and the story tends to center around the rebellious ne'er-do-wells of the underworld, which makes them good guys. So they're always going around being polite, and it really pisses people off, and they're being nice and feeding people and things, and it really much to the chagrin of the other demons. Anyway, it's a delightful series, and I've been enjoying the heck out of it. And you'll notice, I don't know if it's apparent, it must be apparent to you too, that I have my special background behind me today.
Oh, yes. It looks like maybe an anachronistic version of an atom model.
Yes, that is very good. It is, yes, an outmoded concept, but it actually excuse me, overlaps quite well with what I'd kind of like to talk to people about today that I think they might be interested in, because you'll notice that all of those little atoms consist of a red ring and a blue ring and a green ring.
That reminds me of something. Where have I seen that before?
Well, you've seen it inside your eye holes, but the reason it's significant is because there's an even more fundamental thing than an atom.
I was not thinking so much of the RGB as being the three quarks.
Right, that's exactly right. So quarks, just like these cartoonish atoms behind me, come in colors.
Yes.
Uh, and we call them flavors, but there's a spectrum of them, and the rules that define them are called color confinement. Anyway, um, I realize that people have probably heard of the concept of quarks, like they've heard the word. It's a real commercial word, right? Because it starts with a Q, so it grabs people's attention.
People love cues.
It's exactly, Qs are exotic and foreign and magical, mystical. So if you have a word with a Q in it, surely it must be more powerful than normal words.
It's fun to say. Let's just,
It's real fun to say. And so, the physics is just plumb packed with those. There's quarks and the quantum realm. There are cue balls. So anyway, there's that. Popular media loves to borrow terms from physics because the physics has a lot of Q terms. But quarks. So I'm sure everybody's heard of quarks, and not just the bartender from Deep Space Nine, but
Any
the
relation?
particles. What's that?
Any relation?
No relation. Well, I mean, he was full of quarks,
Okay.
made up of quarks. So quarks are, as far as we can tell, the most fundamental particle in nature. And when we say particle in this sense, it's not the common sense. Normally, when somebody thinks of a particle, they think of one Lego from a Lego set or whatever, right? It's just this one little sphere. A particle in the absolute theoretical physics sense just means a point in time in space-time where something's different. Right.
A measurement.
Right. There's something that's not just the background ambient atmosphere. It's just there's something has happened at a point in space-time. That's a particle. So when physicists talk about particles, know that they're not necessarily talking about hoses filled with little spheres that are being blasted at things. It's oftentimes just talking about space-time events that happen at a singular point. So when I say that quarks,
that's a straying a little bit from the common usage of particle, right? And yes. A particle would normally be a physical object, right?
Well, yeah. I mean, like I say, like people hear the word particle and think of maybe like a grain of sand or something.
Right. Or like, so how do we say like a photon, right? Like if we call that a particle of light?
Right. Well, a photon is a particle. It's a particle because it's a point in space-time where there's something happening. It's not just empty space. There's something there.
Yeah.
You picked a photon, and photon just happens to be just about the minimum thing that could ever possibly happen. It turns out there is something lesser that can happen, though, and it's called a quark. And quarks are so small and so fine and so subdimensional to us that they never exist outside of groupings of at least 3, and sometimes higher than that too, up to 5, I think. And so we call these quark triplets. Quark triplets. Every larger particle that we can think of, a proton or an electron or even your precious photon, are made of these quarks. And you might think to yourself, well, if a quark is a particle and a particle is just some kink in the surface of space-time, right? Then what about them makes for a particle? Why is that a particle?
Right.
And the answer is kind of complex, but I'm gonna do my best to give a metaphoric demonstration here that I'm hoping will make it a little more solid in people's heads. Okay. So in physics, we have this concept that many of you have probably heard of entropy, right?
Entropy, yeah.
And broadly speaking, people say more complex systems become less complex, or disorder increases with time, is the classic thing that we say about entropy. And that's sort of an inaccessible statement, but what it means is things don't just stay, a gas won't just stay buzzing and confined on its own inside a box. If it's inside a box and it's buzzing around, it'll eventually bounce around enough to fill up that whole box, right? That's all entropy is. All entropy is the specific traits of a system evaporating over time because the system's becoming homogeneous at the atomic level. or the quantum level actually.
I mean, there's another a way that I've heard it described is like a, I mean, like what you're saying makes sense inside of that too, but that it's like if you have like a bowl full of oranges, it's far more likely that if you spill a bowl of oranges, it'll just randomly spill out into the. It's far less likely that a group of oranges will just randomly roll together into a pile of into a bowl, right?
Right, and in fact, so unlikely is it that we make very concrete statements about things like that. For example, it will never happen. And when we say that, we can make that more specific by saying it'll never happen within the thermodynamic lifespan of our universe. In other words, enough time will never pass for that situation to randomly occur.
But wouldn't that be the best universe where things just sort of like randomly sprung to order?
Well, there's a universe with reverse time to our own where that would happen. The problem is you'd still experience it. You know, if it, for there is no such thing as reverse time. People, let me just put this to bed right now. Okay, time travel is impossible, not because you couldn't travel back in time, but because you're made of a bunch of individual particles that would all be traveling back in time. And since you're not reconfiguring yourself into some sort of weird inverted mutant monster thing, you wouldn't be able to tell the difference as to whether time was rolling forward or backwards, because time rolling forwards is like a big red carpet being unfurled. Time going backwards is like that carpet being rolled back up. But it's not like the path of the carpet changes. It's
Right.
it's the same either direction. No new data comes from being either direction. People assume that when they time travel backwards in time, they'll turn around backwards and walk backwards as everything else is going forwards and whatever. No, you're part of the universe. If you reverse time, you reverse too. Everything reverses at the same time. We're all part of the same, projector sheet.
Right. And, I mean, another, sort of, I don't know, a way to think about this particle, if you consider that like you and I are a sum total of the particles in our body, which, and one way to put it is that's what our physical makeup is. But another way to put that is that is the recording of where we were, not only in time, but in space. Right. So that's another important factor is that like to go back in time.
Yeah. Right. The local environment matters just as much as you do in terms of your makeup. Yeah. No, that's absolutely true. And that's not just true in terms of we eat nutrition and it becomes, you are what you eat or whatever. No, but literally the fundamental physical forces that are affecting you, even though they're following the same rules everywhere, the specific dials are turned to different numbers everywhere. And so, here on Earth, we experience less time than somebody out in space does because we're sitting in a gravity well called the Earth, right? And gravity slows time. So we're experiencing less time on Earth than somebody who's orbiting in a space shuttle, because time's not slowed down for them. Anyway, this is getting way into the weeds. Basically, I just want to note that there's this thing called entropy, and as far as we can tell, it mirrors pretty closely the flow of time. They may be indistinguishable, in fact. And because there's this constant flow going, there can be changes relative to that flow. At some points that flow might get slowed down. At some point, it might even get reversed. And what does that look like to the rest of the flow? Well, the answer is, I've come up with a little diagram here to show us. So here we have entropy, all flowing in one direction. See, I've drawn all the little arrows pointing upward, right? But this is a two-dimensional plane where that flow is happening. If I fold that plane in a higher dimension, you'll see that the higher dimensional data has become encoded as a cube.
Oh, sure.
But the lower dimensional data, the flow data, is still there, right? And what we've created here from our original point of view is three different types of what we would call quarks. This visual representation would be two up quarks. In other words, two of the sides resolved to become up, and one that-away quark. We could call that a down quark, or we could call it whatever we wanted to. But the point of the matter is, it's the folding of the space-time that defines the quarks, not the arrows, right? In other words, the saying that quarks are something is kind of missing the point. It's more like it's like an eddy in the middle of a stream. The eddy isn't really something. The eddy is just behavior of the water. You can identify it. You can
You can
point to it.
define it. You
You can
can
define it. You can
measure
even
it.
make accurate predictions of how that eddy is going to behave relative to its environment.
Mhm.
But that being said, if the river dries up, there's no eddy left. There was no even evidence the eddy was ever there. The eddy, it in and of itself has no existence. It is merely a function of the river, right? And by that same token, a quark is not really its own thing. It's just a function of the flow of time that has been twisted at higher dimensions than our three-dimensional space. So what we have is a three-dimensional space where time is flowing through, entropy is flowing through, and because there are convolutions within that space that are higher dimensional, can't be witnessed within that space, what is instead witnessed is physical behaviors that seem distinctive. So quarks, for example, are charged particles. They have a charge to them. They
Can we
can.
back up just a second, please? Like, so
Sure.
let's think about when you were talking about an eddy, right?
Uh-huh.
That being basically an effect of the water around it, right?
Yes.
So I think for somebody who is maybe just learning about what a quark is, it might be helpful to understand what that represents. What the quarks represents. Yeah, like tell us more about that.
Well, like I say, a quark isn't really a thing. A quark is just
I
a
guess why would it help to know the direction the entropy was going in the quark versus yeah, like so
well.
like
Let me
yeah.
put it a different way, and this will actually get into how physicists deal with these problems. If you take a rope and you tie a knot in it, okay, that knot's not going to go away on its own, right? You haven't really done anything to the rope. The rope has the exact same mass as it did before. It takes up the exact same volume, right? Uh, but you've added information to that system. You've tied a knot in it. That rope is ostensibly a one-dimensional line, right? And you put a three-dimensional twist in it. We three-dimensional creatures can see that three-dimensional twist. We can interact with that three-dimensional twist. But it would be wrong to say that the rope is a knot at that point. That knot could occur anywhere. That knot was more about the interactions that the rope had with the universe around it than it has anything to do with the rope itself, right? In other words, a quark is like a particle whose only presence that we're aware of is the behavioral change that we've seen in the larger things around it.
Okay, that's helpful. Thank you. Yeah.
Sure. Um, so because of that, because the quarks themselves are just sort of movement phenomena, not what you'd think of as a solid thing. They can wind up interacting with any and all of the forces. In other words, because they're not massive particles themselves, they don't have to find creative ways to return to a ground state. I mean, that's a complicated thing to say, but basically everything can be made up of quarks because quarks are capable of feeling every force. They're capable of interacting with every force in the universe, and and that might be kind of a wag the dog way to put it. It might simply be that every force we experience in the universe exists because that's what quarks are capable of experiencing. Ways that quarks are capable of behaving. Who knows? We don't really know anything about that, but
It would seem though that if you knew the position or yeah the position of the occurrence of three of those phenomena, that you would be able to pinpoint a something, right? Like that if you had some way of knowing like where all three where they existed in the universe, would that give you any new data?
What would so? Imagine that quarks are ingredients and that a particle is a soup. Okay, so you can make that soup more or less spicy by adjusting one slider. You can make that soup more or less meaty by adjusting a different slider or whatever. But before you put any of those ingredients in that soup, none of them are soup. They're all just ingredients. They're all just constituent components. So you could say what region of this kitchen has spices in it, and that would tell you something. But it wouldn't that it wouldn't be like you were discussing a specific object within that kitchen, right? So when what matters is whether or not the soup is spicy, not whether or not there's a region that is spicier than a different region within the environment. So in other words, quarks are clustered together in terms of in threes, probably because without the other two being around, the one remaining one would just be part of the background field. There would be no, in other words, it's being pinned in place by the presence of the other two, aberrations that are going on, whatever those might be. That or at least that's why we think it is. One of the actual reason that quarks aren't seen outside of a triple bond is that when you stretch a quark triplet apart, eventually it becomes a lower energy state just simply to split that into two groupings of you've added enough energy to create three new quarks, and so you've created a new triplet, and at that point the system just splits into two new triplet sets. In other words, part of why we only see quark triplets is because of the elasticity of space-time, the specific elasticity of space-time. In other words, if you were to try to get more quark, if you were trying to string together more quarks than that, they would always just snap down into the next available triplet grouping, because that's always going to be a lower energy option than a more than triplet grouping.
Okay. And would that, would that look differently in your folded model?
Yes. Yeah, right. Yeah, okay, good call. So, yeah, right. So what you would be doing in this model, right, is, so obviously I'm folding the paper to achieve this shape, but in theory, if I folded it hard enough, I would cause the paper to pass through itself, and I'd section off each one of these individual little guys, right? I mean, God, how can I rectify this? So if I tried to apply the amount of energy that it would take to pull off one of these little guys, of these three, right? All I'd wind up doing is putting so much energy into the system that I'd put an amount of energy into the system equal to the guy that I was trying to pull off. And this system would then just have a new little guy replacing that one. And the one that I pulled off would produce two little new ones attached to it, because I would have put three quarks of energy into the system. The point of energy that would break off a quark from a quark triplet is exactly enough to create two new quark triplets.
Which is also why they are always in threes as well, right? Like there's not ever an imbalance of.
Yeah, well, like I say, there's up to a pentaquark.
Right.
There are quark triplets and tetraquarks and pentaquarks, but there's no hexaquark, because that's just two quarks. That's two quark triplets.
Interesting. All the different flavors.
Yeah.
All living in different villages.
Yeah, and
Can you talk a little bit about Yeah, something that I think is interesting is oh, and you'll be able to tell me the name of the work. But basically, it's the physicist philosopher who wrote about the society, the one-dimensional society, or the two-dimensional society rather.
Oh, you're talking about Flatland.
Yeah, excuse me, Flatland. Yes, can you talk about Flatland at all? Kind of, I think that'd just be a
Yeah, as an introduction to what higher and lower dimensional.
yeah, I think that would be a good place to kind of like take this a little bit in that, we're kind of
Sure.
exploring the dimensionality of the universe
Right.
and, we're talking about folding the universe. So let's start like real simple. Let's
Sure.
start on a piece of paper.
Yeah. Okay. So yeah, we'll start with Flatland, which is by a female mathematician. I can't remember her name. We'll look it up later. Put it in the hashtags. Anyway, the idea being Flatland is this two-dimensional universe, and all the inhabitants are two-dimensional, and there are things like triangles and squares and circles and things. But the book deals with the difference between their point of view and what our three-dimensional point of view would be. So when a Flatlander who's, say, a circle living in the infinite plane of Flatland encounters a triangle, he doesn't see a triangle. He sees two lines coming towards him that meet in the middle, right? Or he's looking at a different side of the triangle and he just sees a flat line coming towards him, right? Because he can't see above or below that triangle. He can only see it edge on because he himself is only an edge on being. So Flatland is a way to help us visualize what happens when you delete a dimension from perception, right? And the answer, winds up being that your vision collapses just to a line, and that line is segmented into whatever's immediately in front of you, and it doesn't have any above and it doesn't have any below. The entire universe is just that one little line that your eyes are at. And so all the data that you could ever get is just, you draw a cone out from your eyes, and that flat fan-shaped visual field out from your eyes uh, is all that you'll ever be able to perceive. You couldn't picture what a box is because that goes into angles that you can't perceive. Literally, your visual abilities don't. If you're drawn on this piece of paper,
Mm-hmm.
and you and I, a big three-dimensional God being, decide to fold it, what does that mean to you? Nothing. Those arrows are all in the same place. They're all positioned relative to one another exactly the same. This little arrow right here is still just next to this little guy and next to this little guy, even if I fold it, no matter how I fold it. Right. So they
is from our standpoint as three-dimensional beings, if we were to look at the Flatlanders, it would look like a flat map of like their house would look like a drawing of a box or whatever.
box, right? Exactly.
Right.
And there are a number of useful illustrations that this model provides us, not the least of which is that as three-dimensional beings, and this is true of any higher dimensional being looking down the lower dimension, as three-dimensional beings, we can look down in Flatland and we can gather endlessly more data than any Flatlander could. All objects in Flatland to us, a three-dimensional being, are completely visible inside and out at all times. We can see all sides of them, including their interior, all the time. When you look down at a triangle, you get to see all three sides of it, plus the interior of that triangle. Whereas a Flatlander would just get to see a line in front of him, right? It wouldn't know what's behind that triangle. It certainly wouldn't know what's inside that triangle. But
and to us, it would be as preposterous as saying that you had the ability to see an object that was either inside, outside, above, or below your house.
Well, yeah. Imagine as a fourth dimensional being coming here to the third dimension and talking to somebody and being like, "Oh, there's a person chopping onions in their kitchen over there," and you're like, "Well, how do you know that?" And you're like, "Well, I can see it from here."
Right.
Even though that it turns out the kitchen they're referring to is deep underground. It does, and the answer is they're seeing it along a curve that doesn't, along a trajectory that doesn't exist within three dimensions.
So just as in Flatland, we would be able to see the triangle in the kitchen cutting onions,
Right.
even
Even if he'd shut all his doors, we'd
we
still
were
be
across the,
right.
across the yard in the gazebo that also just looked like, a little hexagon on the lawn.
Right, or whatever. Yeah. And and it wouldn't it wouldn't seem strange to us at all. In fact, it seems perfectly natural that we'd be able to see all those things simultaneously. Into a
Yeah.
fourth dimensional creature, it would be perfectly natural that they could see the inner workings of our, you know, pulmonary system as they were talking to us. It would just be visible, just openly visible to them. That's not to say that there's any light shining on it at the moment. If you were to see a cross section of my pelvis right now, you'd basically just see a black oval, because there's not a ton of light rattling around in there. So it's, unless they have some sort of weird fourth dimensional light too. Who knows?
I mean, it might not even matter. Like, you might not even be seeing the light bouncing off of it.
No,
Right?
well, right. Right. I mean, it's once we're talking about it, the visual organs of a fourth dimensional being. I mean, I'll tell you this much: I don't even know how the visual organs of a two-dimensional being would work.
Right.
Like, 3 dimensions is where our expertise lies.
Right. Just don't let our ignorance of the fourth dimensional plane.
Right. No. That. Right. No. Please don't let that curb the numinescence of this topic. There's so many fun things. The Flatlanders might not notice when you fold the page and create higher dimensional structures that they have no idea about. But what they would notice is the impact of the physical laws. So, for example, it might now be possible for a Flatlander to, say, brush up against its own forehead because you folded the paper. And that wouldn't make any sense to the Flatlander because that doesn't visually line up. I mean, it doesn't, its forehead's nowhere near its little palm or whatever. But
would it even know if that was happening?
Well, it would if there's any force within their universe, any constituent force within their universe that makes them up that is not merely two-dimensional. I mean, I can tell you for as close to a fact as comes in theoretical physics that we human beings are made up of particles which definitely have vectors of motion beyond 3 dimensions. And I'm not saying that in some sort of weird pseudo-religious way. I mean, literally every particle in our body is capable of certain kinds of motion that are not confined to 3 dimensions. And the math behind that is very complicated, but if a higher dimensional being, what's that?
I mean, I that is so far away from anything I've ever heard. What is that? Can
Okay,
you give an example of that?
If a Flatlander, okay, let's imagine it this way. Imagine that the particle forces within a Flatlander are, to the Flatlander, are all two-dimensional, but we know that they have higher dimensional vibrations. You might see from a three-dimensional perspective, if you're looking above or below that plane, that where each Flatlander is, there's a slight glow or something, right? And the Flatlanders could never be aware of that glow. It's literally not accessible to them. That data is outside of their plane of existence. It's still part of them. It's still part of their total physical set of information. They're just not capable of sensing it directly. So like I say, we have all these higher dimensional motions that our particles are capable of going through. If a fourth dimensional creature looked at a human being, they'd see a flatly three-dimensional being who was covered in all these little balls of higher dimensional movement. It might actually be confusing to them, being like, well, why don't you guys just move in higher dimensions? I mean, parts of you are in higher dimensions.
Right.
That would be like,
it'd be like asking us, like, why, how, I don't know. And it's just a matter of perception as well, right? Like, it's just not having the tools to.
Well, right. And it's not like you can't learn. That's the thing. People think that just because it's not the mode in which our evolutionary biology intended us to pursue, it doesn't mean that you can't learn to translate. I mean, in a very real way, when you read a book and you're looking at all these symbols and you're deriving information from it, you're picking up real data. I mean, there's real data there, right? But you're looking at a different time and place. There's some weird visual forming inside your skull that has nothing to do with your external reality. I mean, it's just, it's um we have the abstraction capacity that allows us to visualize things that we haven't experienced before.
Well, there's another aspect of that what kind of surprised me the first time that you explained it to me, and it was very much unintuitive, which is as a three-dimensional creature, you pointed out that I don't know if we'll be able to see this. We won't be able to. All right. Well, gotta find something that's like box-like and will be picked up by our sensors here. Um, you mentioned to me that as a three-dimensional creature, I could only ever see three sides of this at once.
Right, or any
I
cube.
thought that can't be right. Like I mean, certainly there's got to be a way I can turn it so that I can see more than three sides.
Nope.
But no, like there just isn't ever a way that with the naked eye I can turn this in such a way that ever there are more than three sides facing me.
Right, and that is purely a function of rectilinear three-dimensional space.
Well, makes sense, right? That's how
Yeah.
we adapted to see the universe. But it's not to say that the other information doesn't exist.
Isn't there, right? No, and one demonstration that I was able to, I'm sure this is probably what you were angling at. A demonstration that I was able to give you that I can't give you here online because of the monoscopic nature of webcams, which is that if you take a big lens, like a big old magnifying glass like that, and you in 3 dimensions hold an object, a nice square, nice sharp edges, sharp corners, square object behind it, and to touch the lens, you'll notice you can see actually 5 sides at the same time. And you might think, oh, well, duh, it's just the lens bending light. Well, yeah, but guess what any space-time curvature is?
Right.
Right. So yeah, there is, you can set up, and it's not like the lens is liquid or something. I mean, it's not, that's a region of space where there is a permanent adjustment to the flow of light, right? Is one way to put it. But it's extremely analogous to, non-material objects, in that exact same way, that just as much as looking through that magnifying glass and being able to see 5 sides of that box at once is nothing miraculous, right? It seems very straightforward when you're viewing it. So too would be learning to view the universe and recognize it when 2 phenomena were connected by a higher dimensional causal string. Now,
I mean, it definitely doesn't look natural, but it doesn't look that unfamiliar.
No, there is a discernible logic to it. That's the difference. That's the difference between a higher dimensional incident and magic or something. Is that with higher dimensional causal relationships, even if they seem bizarre to a lower dimensional creature, always do line up. The math, the numbers always add up. The sum's always total. It's not like things really are teleporting or really are, whatever, being brought into existence suddenly. It's that they were occupying some other region of space which they're not currently occupying, and they are currently occupying your region of space, and so they had, that area deflated a little bit with mass and your area inflated a little bit with mass, but it's always a zero-sum game.
Like, this is not that closely related, but it reminds me of there was some discussion online about why art in the early Middle Ages was so, the proportions were not even close to accurate, and it wasn't they were even, it didn't seem like they were even attempting, or as though there was some kind of breakthrough that was necessary for art to understand that there was some kind of
even though the Greeks got it. I mean,
it wasn't, apparently it was, I mean, at least the take that I saw was that it was a kind of a deliberate stylistic choice, and it wasn't that they didn't have that. which, it does seem odd, but
Oh
I
yes,
don't.
my art is reverently bad.
Well, it seemed like it has no reference material,
Yeah,
I mean, which is odd because
yeah, we've all seen pictures of like medieval paintings of babies and horses and things where they just look like some sort of awful mistake of nature.
well, not only that, but like, they'll have a woman seated on a chair that is, structurally
Right,
unsound.
just
The
could
planet,
not work. Yeah,
right?
right.
So, it's like, how did they obviously they were in the same room, but maybe not obviously, right? If they were painting from
Yeah,
life, it wouldn't have looked like that.
sure.
But then, it maybe wasn't the point to have it be captured to scale. And
Yeah, another aspect that I don't, I can't. This will be a conjectural statement. I can't claim any real expertise on this subject, but I imagine that the there is a really undervalued academic aspect to art. In other words, the development of art parallels the, a social refinement of the subject over time. And obviously that's manifestly true in the sense that like paintings got better and better and better over time or whatever. But I also think that there's just an intellectual discipline that comes with academia that also lends itself to being able to realistically portray things and stuff like that, right? So like I said, like the Greeks had realistic like drawings and sculpture and whatever, and but they also had this like intense academic tradition. Like they'd have schools of art. You'd go to a sculpting school or you'd go to a painting school or whatever. Right. Whereas in the Middle Ages, it's just like, oh, well, yeah, one of my vassal's nieces seemed like she was pretty good at drawing. And so we stole her and to the castle now.
right, this is a fixture now. Currently,
Right. Who does our paintings for us?
Yeah. Yeah, I get that. Yeah. Well, and then so okay, so gotcha. So it could depending on your native perspective, you may have more access to intuitive grasp of the dimensions, but also
But I also think that there's this intellectual aspect that's not that, like I say, is like undervalued. I don't know, maybe not by artists, but I think certainly by the common conceptualization of artists, which is that artists are creative types, whereas uh, scientists are thinker, whatever calculative types. But it's not. I honestly think that you're a better artist if you go and study anatomy or whatever. You know what I mean? Like, I don't think that that's just a stretch on my part.
right, right, right. Yeah, no, it's and I mean, it's interesting because it's today it seems a lot more primitive in that the people who would be creating art like that would be either typically young or in the
Right. They certainly wouldn't be considered professional grade. Like,
but in the model of like cubist, I mean, Picasso said that it was very difficult. Like, he had to very deliberately train himself to.
Yeah, but remember that Picasso, before he got into his various ultra stylized periods, could draw photographically.
Sure, that's what I mean. It's not intuitive, right, to draw like that. You
No,
have to
right.
train yourself in order to.
But I don't think that's what's going on with it, because there are a couple of things that like clearly they fetishized. I mean, clearly even the really crappy medieval tapestries where like I say, like the horses look like giant rabbits or whatever.
Tapestries.
Yeah, that they'll still have gotten things like the shading of the textiles right, like the fabric, flowing fabric.
No, that's the funny thing is that like, why skimp there?
Yeah, right. Yeah, right. Like your baby is cross-eyed, like clearly cross-eyed.
Yeah.
Why did you go into such realistic detail, painting that gold orb in that guy's hand?
Yeah, I mean, maybe outsource it, right? I got a Halo guy and I got a colorist, and I got a guy that does teeth, and then how I do with hands, so
You have to bring in your hand guy.
got a hand guy.
Yeah, well, the other thing is that sometimes I think that there's just, well, I think that periods of time, I think that there are, much in the same way that like mass extinctions are driven by like climate change or like whatever. environmental elements. I think that if you have, as a society, a big, crazy, long period without wars, then it's like you have the time to navel gaze enough to really become sophisticated about art. And that, like, basically medieval Europe was nothing but wars for 1500 years plus.
You're sending all the artists to the front lines first.
Right. Well, yeah, right.
Artists needed.
My favorite idea. Do you know about the concept of ribaldry?
I know the word and what it means, but I guess is it a more formal version than I'm
There
knowing?
is, and I don't want to get it wrong, so I'm going to look it up. But it's just too delightful. You're going to love it.
Okay.
Okay.
Hmm?
Right.
Here's the definition of ribaldry: amusingly coarse or irreverent talk or behavior.
Okay.
Oh my goodness, I can't find that. Well, just the idea that there would be this company of soldiers who weren't really soldiers. They weren't trained as anything. They're just farmers. They were the dregs. Homeless guys that got rounded up or whatever, and that they'd get sent out on the front lines first, and that their whole point of them was just to make total asses of themselves. Flip off the enemy, moon them, whatever, make lewd jokes and yell obscenities at them, just purely as a weak attempt at morale damage. And that's it. And then they were expected to die as the enemy advanced.
Okay.
Yeah.
So these are like our COVID protesters in the modern era, probably.
Yeah, very much so.
Yeah. Well,
The king has
it is entertaining.
Yeah. Oh, yeah. I mean,
I mean, I kind of worry about what comes afterwards, but
yeah, right.
And it's like absurd, and I get it. So yeah, this seems very topical. Incidentally, we have some news from our marketing department.
Oh,
Yeah, just wanted to remind you that this weekend, Pettitshire, our online shop is having a sale. Yeah, so we've got all kinds of new merchandise to choose from. All kinds of designs and let's see, like pan pals, for example, something that we're very excited to now offer, although we're temporarily on hold, is our new line of Pettitshire pan pal masks.
what?
Yeah, right.
Oh my god!
Stylish and currently out of stock, so we expect to get those in soon. So be sure and check out tpublic.com/Pettitshire and check out our deals. Just this weekend only, we are offering. Yeah, boy, that's a good deal on those. But we've got all kinds of other fun things, including tote bags for the shoppers and all of us, or the picnickers, and we've got our pins and pillows, and even onesies for the little ones. So we'll post a link to that down in the doobly-doo, and we'll see you then.
That's amazing.
Yeah.
Oh, the things you get up to in this pandemic, brother.
I know, right? Idle hands, as they say. Idle hands.
Are the pandemics playthings?
Pandemics play. Oh, that's a good idea. We ought to develop a line of pandemics playthings. If you have any ideas or suggestions for pandemic playthings,
feel free to email them to us or send them to us at post office box.
Facts.gopher.net. Well, my brother, it looks like we're at the top of another hour.
It's wild. It's crazy.
It's wild. It's
wild and crazy.
Like time flies when you're having fun.
Yes, indeed. Yes.
We managed to stave off another week of pandemic madness.
Yes, that's
There's
right.
no
No, that's
tail.
right.
All is happy and hearty in the land.
Mhm.
Yeah, just don't look outside or ask
No,
too many questions.
right, or think too much about what's happening.
Yeah. But in the meantime, we definitely encourage you to stay curious, keep those questions safely rolling, and until our next time, we're wishing you the best of the week.
And a safe return to us next time.
All right. Bye-bye.